Hello everyone. You know, this limiting factor thing is really tiring. And if you're anything like me, your brain is probably a bit dead by now. So I'd suggest go and take a sip of water, go and take a short break, close your eyes for a while, say hi to Mr. Pratap. And yeah, once you're done, come back and sit down and let's get going with more examples of graphs and limiting factors. Alright, welcome back. You know why we're going through these graphs, right? Because actually these are, a lot of it comes out for the questions in the exams. That's one reason. And the other reason is actually you're training yourself to read and understand graphs better. And in the future, you're going to see a lot of different kind of graphs and information. And it's a good skill to know how to read graphs. So let's get going with this example. Remember I said that this graph shows rate of photosynthesis versus carbon dioxide concentration. Take note, it is not light intensity. Okay, so one common question they'll ask you is, what is the limiting factor at this point here? At point A, notice that carbon dioxide concentration is very low, right? So what do you think is the limiting factor at this point? Well, the limiting factor at this point is carbon dioxide concentration. Why? Because you can see that as carbon dioxide concentration increases from A to B, the rate of photosynthesis also increases. So clearly, it is the carbon dioxide concentration that is holding photosynthesis back, that is limiting photosynthesis. So from point A to point B, the limiting factor is carbon dioxide concentration. Now, how about point C? What is the limiting factor there? Well, if you apply what we learned about the graph about light intensity and rate of photosynthesis just now, this is exactly the same except that it's about carbon dioxide concentration. So at point C, the limiting factor is not carbon dioxide concentration, right? Because as we increase the carbon dioxide concentration from point C, imagine if we increase the carbon dioxide concentration, the rate of photosynthesis does not increase further. It remains constant, right? So this tells us that the carbon dioxide concentration is not the factor that is limiting the rate of photosynthesis. Something else is, and it could be light or temperature. So, is it light or is it temperature at point C? Well, we can't tell from this kind of graph where there's only one curve. However, we can tell if there are graphs with more than one curve, such as this. Ta-da! Now this is a complicated graph, but don't worry, we're going to go through it together. Now this graph has two curves, and I want you to focus on the lower curve first. This curve says low light intensity at 30 degrees Celsius. What does that mean? Well, that means that we're taking the data from a plant that is being grown at low light intensity. So imagine this is my underwater plant again in a test tube. And I'm putting it at a very low light intensity. So this is my light and it's a very low intensity. And at 30 degrees Celsius. Now what I do is that I expose this plant to different carbon dioxide concentrations. 0%, 5%, 10% carbon dioxide concentration. Right, so let's say at 0%, you can see that the rate of photosynthesis is about 0. Right, let's say at about 5%, the rate of photosynthesis is something like 5. Let's say like, okay, these are all my own values. And let's say at about 10%, right, the rate of photosynthesis is about 10. Right, so we plot the points for this plant, and that's how we get this first curve. Now, how do you get the second curve? Imagine now I take this plant, the same plant, and I shift it into a different situation. Now, I shift the plant into a higher light intensity, a very high, strong light, a strong light intensity, but still 30 degrees Celsius, right? Still 30 degrees Celsius. And I do the same thing again. I expose it to different concentrations of carbon dioxide, 0% carbon dioxide, 5% and 10%, and I measure the rate of photosynthesis at each carbon dioxide concentration. So for example, at 0%, well, the rate of photosynthesis is about 0 as well. And now at 5%, the rate of photosynthesis is actually higher than 10, right? So it's this point here, maybe about 12, right? And then at about 10%, you can see that the rate of photosynthesis is about, maybe let's give it a value of about 25 units. So that's how we get the second curve, right? It's from a plant, the plant grown in a high light intensity at 30 degrees, and then we just change the carbon dioxide concentration and measure the rate of photosynthesis at each concentration. Alright, so how do we actually interpret the graph and talk about limiting factors? Well, first at point A, what is the limiting factor? Now if I'm talking about point A, then you just need to focus on this curve, the lower curve. And at point A, the limiting factor is carbon dioxide concentration. Now why? Because you can see that as carbon dioxide concentration increases from point A, looking at the lower curve, the rate of photosynthesis also increases, right? So it's carbon dioxide concentration that is the limiting factor. So let's talk now about point B. Now at point B, what is the limiting factor? So again, focus on the lower curve because point B is on the lower curve. At point B, the limiting factor is not carbon dioxide concentration, right? Because as we increase the carbon dioxide concentration, when we increase it, the rate of photosynthesis does not increase further. That's why the curve here is flat, right? The rate of photosynthesis did not increase further. So what is the limiting factor at point B? Well, we said just now that it could be light or it could be temperature. So which one is it? Now, if we just looked at the lower curve, you will not be able to tell whether the limiting factor at B is light or temperature. However, if you compare the lower curve to the upper curve, you'll be able to tell that the limiting factor at B is actually light intensity. Now that's because at point B, if I increase my light intensity at point B, the rate of photosynthesis will actually increase. Now how do I know that? Well, it's by looking at point B more closely. So let's look at point B and the conditions at point B. So at point B, you can see that it is a low light intensity because it's on this lower curve. Low light intensity and 30 degrees Celsius, and it has a carbon dioxide concentration of, let's say about 20%. Let's say this point is 20%. Now at low light intensity, 30 degrees Celsius, 20% carbon dioxide, the rate of photosynthesis was, let's say, around 10 units. Okay, let's say this point is 10 units. Now let's take a different point, and that is by using the upper curve here. So let's imagine that 20% carbon dioxide concentration, right? I want to extend this and find a point on this top curve here. Let's call this point B with increased light intensity, right? So let's call this point B with increased light. Now at B with increased light, what are the conditions? Because B with increased light is on this top curve, the conditions is high light intensity, 30 degrees Celsius, and still 20% carbon dioxide concentration. So at 20% carbon dioxide, 30 degrees Celsius, and high light intensity, the rate of photosynthesis, let's say, is about 20 units. So let's compare point B with B increased light. And you can see that when I increase the light intensity from low to high, the rate of photosynthesis actually increased. So at point B, the limiting factor is light intensity. And I got that by comparing the two curves together. Now finally, let's talk about point C. Now point C, the limiting factor is very simple. Just focus on the top curve. So at point C, the limiting factor is not carbon dioxide concentration, right? Because you can see that when you increase the carbon dioxide concentration from point C, if I increase the carbon dioxide concentration, the rate of photosynthesis does not increase further. The curve remains flat. So the limiting factor is not carbon dioxide concentration, and it could be either light intensity or temperature. Right, in this case, I can't tell because there's no other curve that is above point C. Alright, and now we're going to look at this final example together. Okay, this is 3 curves in one graph. Right, so brace yourself. Have a look at the graph first. Try to make some sense of it, and I'll explain it in a while. So, what is the limiting factor at point A? The conditions at point A are this: 25 degrees Celsius, 0.4% carbon dioxide, and light intensity of Y. Okay, so at this point, what is the limiting factor? Well, the limiting factor at this point is light intensity. Why? Because, as we look at this top curve only, as we increase the light intensity, the rate of photosynthesis increases, right? Looking at this top curve. So the limiting factor is light intensity. Now, how about point B? So let's think about point B and what are the conditions at point B first. So point B is on this curve. So point B is at 25 degrees, 0.04% carbon dioxide, and Y amount of light. So what's the limiting factor here? Well, firstly, we can say that it is not light intensity, right? Because when we look in this direction, when I increase light intensity more from point B, there's no change in the rate of photosynthesis. So light is not the limiting factor. But I can compare point B to point A, right? So I imagine that if I compare B and A, means that I increase the carbon dioxide concentration. So if I increase the carbon dioxide concentration from 0.04 to 0.4%, you find that the rate of photosynthesis increases, right? Comparing point B and point A. So the limiting factor at point B is carbon dioxide concentration. Now finally, how about point C? Now at point C, what are the conditions? So just looking at this curve, the conditions is 15 degrees Celsius, 0.04% carbon dioxide concentration, and a light intensity of Y. So we can first say that the limiting factor is not light intensity. Because when we look at this curve alone, right, as you increase the light intensity from point C in this direction, right, the rate of photosynthesis did not change. It remains constant. It doesn't increase further. So light intensity is not the limiting factor. So what can we compare C with? Well, we could compare C with B, right? Because C and B, they are both at the same light intensity Y. They are both at the same carbon dioxide concentration, 0.04. But the difference is B is at a higher temperature. So, when temperature is increased from 15 degrees to 25 degrees, then we saw that the rate of photosynthesis actually increases. So the limiting factor at point C is temperature. Okay, I know that's all really tough, so just take some time to absorb it. If you need help, ask the teacher for help. Just one more short video after this, and it has to do with the relationship between rate of photosynthesis and temperature. So this is the rate of photosynthesis at different temperatures. And it should look very familiar to you, thinking back on some of the chapters that you've already seen. So the next video will be really short and really fast. Alright, see you there.